Okay. Let's do a check. Hello? Can you hear me? Sounds like it. Good day and welcome to Amsterdam on behalf of Microsoft. I thank you that you're spending the time with us this week to get some insights into what we're up to and what's going on. My name is Uli Hohmann. I'm the Chief Architect for the Microsoft Consulting Organization. And I wanted to talk to you about the trends, the patterns, the things we are seeing that are influencing modern applications. Most of you will be software developers that are thinking, what's going on in the world and what do I need to pay attention to when I'm thinking about my next application or the application in my enterprises? What are the influence factors that we are seeing really driving a lot of industries, regardless if they're oil and gas or financial services, logistics, transportation? All of the people are following similar trends. Some of them will be fairly obvious because they have been talked about since quite some time, consumerization of IT, devices, and so forth. But some of them might be less obvious, and so I appreciate you coming in a lot of numbers, which is very unusual for an architecture track inside TechEd. But I'm very happy that we have so many people being interested in this discussion. Everybody keeps talking that applications somehow got easier to build, and that it's now more than ever productive to build software and so forth. And that's certainly true. Tools have become much more impressive. We have a lot of interesting support from compilers, IDEs, and so forth. So the way I describe it generally is the easy things got easier, but things didn't get easier overall. Because you need to think about multiple form factors now. In the good old days, it was fairly easy. Either you wrote to a terminal, that's really the very good old days, or you go into a desktop environment and you had to deal with Windows in its various forms, and that's about it. Some of you also targeted Apple, fair enough. But 10 years ago, the world was relatively simple. Now you have to think about mobility, various form factors, various operating systems, and so forth. And while HTML5 and so forth will make life easier, if you really want to use the device, you have no choice. And so part of this is becoming very, very interesting from a choice perspective. Where are you investing your time to really optimize the environment? The other piece that specifically enterprise IT is not necessarily struggling with, but certainly is thinking through what it means, is anytime access. You used to have downtime where you could actually schedule maintenance tasks, the famous database reindexing or backup tasks or other things, which now, when you look at all the crazy people, meaning us, carrying around these things, where we 7x24 check emails, check statuses of whatever artifact that we are interested in. And a lot of big customers that I know are really terrified of turning on the mobile wave, and nobody can avoid it, so they have to think through what's going on. Now, form factors and so forth have been talked about a lot, but what about all these other choices? If you go to the Windows Azure talk, I don't know if Scott or anybody talked here today or yesterday, he talks about Node.js, he talks about PHP support, he talks about MongoDB, he talks about all sorts of things. So NoSQL, SQL, caching, all these things, what decisions are you going to make? I'm going to talk you through some of the stuff that we as services are doing with our large customers, but there is a lot of choice you have to make as developers that is not necessarily easy. Because for every choice you make, there's a consequence. NoSQL has some very nice attributes, but it also means you're losing ACID transactions. And we all have been nestled on the security and the safety of ACID transactions. The database has been a lot of our friend, and now we are challenging the database as a key building block. So part of this is, can we really do it? Can we still build these reliable 5 nines, whatever the application availability is that you are used to, without actually writing a lot of code yourself? Identity. I hope that a lot of you as developers are thinking through what federated identity means for you, how you're integrating these things. I'm not going to talk about it because there's lots and lots of discussions. Hi, Klaus, grüß dich. And part of this is we as developers have to really think through how do we deal with this. Ideally, we don't see any application thinking about managing user identity themselves anymore. I still see some of it, but it's certainly something that you shouldn't be doing anymore, and think about what that means for your application. Last but not least, the social thing. And I'm meaning social thing because in a lot of ways, nobody has really yet cracked what social could mean for enterprise applications or for big applications. Facebook is clearly one side of social, and they have done an awesome job of explaining to us what ups and downs means and crowdsourcing and all sorts of other things. But I think there is more to be thought about when you think about applications and the social space. What does social mean for an online banking app? I have no idea. I'm not an online banking designer. But expectations will rise where people start to think about, when I interact with any application, I would like to give feedback, for example, to the developer. I don't like the way you're doing this, or I love the way you're doing this. Simple things like that is something that we should think about to build in, because it is the two-way web, or Web 3.0, whatever you want to call it. And that's certainly something to think about when you build your apps. So while it is seemingly easier, because you have lots of choices, great tools, there's a lot of complexity that wasn't there 10 years ago, 12 years ago. And it's not going to get any easier, as you will see. The other thing that you will see is that a lot of dependencies that you used to control yourself, and a lot of ways for you to think about your application, that it's all about the app, as we so nicely say in our private cloud discussions, but it's all about the app behaving as part of an infrastructure. Because the infrastructure guys are starting to become fairly optimized, virtualized, and so forth. And you as an application have to meet those expectations. Meaning you can't really say, I am grabbing memory and I'm grabbing my resources and I'm going to stay stable. They expect you now to think about, hey, if I need to remove resources from you, please give back those resources. And don't expect that all these resources are always available for you, because they might not be. The VMware people call it overcommit. We call it dynamic memory. So there's a lot of tricks the hypervisor play to increase the density. And so a lot of this is something that an application today really doesn't think a lot about. I know a lot of application designers, especially in higher-end applications, that still design how many network cards do they want, what type of network cards, et cetera, et cetera. So they go very, very, very low level. And those things are certainly something that we need to think about. The cost of IT, when you look at scaled for worst case, I do capacity planning like this, and effectively add 25%, or whatever your safety margin is, which of course means that you have a lot of resources out there that are not really used. And as an application, I'm now being asked to think about, how do I become more efficient? How do I use less resources to still get the job done? And remember, there are more jobs to be done. You now need to be social, you need to run on multiple devices, and so forth. So a lot of pressure on us as poor little application people to really make things happen. This is a slide of Windows Azure that illustrates another point that will hit us in a positive sense, but also in a sense from an application design perspective we have to start thinking about. Windows Azure as an ecosystem can be decomposed into a bunch of services. I always joke that people overestimate what can be done in 2 years and underestimate what can be done in 10 years. When I was running around with SOA, that was 2004, 2003, that kind of thing, it was really hard to do. And most people tried it, and it certainly did EAI. Some of them actually managed to do SOA, but not very many. But if you look around now with Amazon, Google, Azure, and all these other guys, you now see SOA. You actually see that we have building blocks that you can choose to build your applications on. And those applications will actually be services using REST-based APIs as the core means of doing things. And, whoops, a little bit too fast. and a lot of ways for you to use either Node.js or .NET or PHP or Java abstractions for you to become, have easier access to these services. While that is all good news, there is a lot of choice for you guys. Again, databases, NoSQL, SQL, caches, message buses, and so forth. And flip the question around, a lot of your applications will now be accessed via code. So where is your REST-based API strategy so that another person might use you as a set of services rather than as an application in the classic sense? So a lot of this is becoming complicated rather than easier. Richer, certainly you can make money on commerce and so forth, but it's something to think about. The other piece to think about is it's global. I don't know how many customers you have that are running around accessing solutions from China in Europe or from Europe in New Zealand. I have no idea. Again, I don't know you guys. But a lot of my customers are struggling with how do they do that. Because latency, as we will talk a lot about, is actually something that unfortunately still matters. I know that the Swiss guys think that they have beaten the speed of light. I've not seen it yet, and I've certainly not seen network infrastructure that can deal with it. But the world is becoming bigger in terms of application access, in terms of data usage, and so forth. Coupled with the cloud in terms of services, REST, and so forth, come a lot of expectation what you can do with the cloud. And while we as Microsoft, for example, talk about it in terms of Windows Azure, actually what we're really talking about is you developing the apps that behave like this. Because while Azure helps you, it really is the application that makes these patterns happen. So predictable bursting, for example, Papa Murphy's or one of the other pizza chains in the US actually has 40% of their yearly business on one Sunday in January. It's Super Bowl Sunday. That's when apparently America decides to eat pizza. And they effectively know on that January they need effectively 40% of their entire year's capacity. So it's very predictable. We have companies that are in the risk management business that are growing so incredibly fast that they now are hiring 30,000 cores from Microsoft for 4 hours a night. So they're doing their calculations and runs on these in this 4 hour on 30,000 cores. So there's a lot of expectations in terms of what's going on. On and off is a simple little trick where you can save money. So on Windows Azure or any public cloud environment, this is real money. If you don't use resources, guess what? They don't cost you anything. And application designers will now be asked by their business sponsors, how many resources are you using? Maybe they're not as smart yet, but I've seen CIOs now effectively having a little spreadsheet where they actually have the Azure and Amazon pricing for VMs and storage, and they're asking their IT shop, how many of those do you need? And why is your VM so much more expensive than the one on Amazon? So we are seeing a transparency increase in terms of resources that eventually will trickle down to developers. So while it's cheap to have lots of memory, you now need to be thinking about, do I need all this memory all the time? Do I need the business functionality all the time? Think about a very classic example, the good old payroll. Microsoft used to run PeopleSoft as our payroll system. We are now running SAP as our payroll system, just for completeness. In '95, I was involved in looking at could we use these incredibly expensive 8-way servers that were effectively running for 2 days a month for something else. And we decided not to because we like to get paid, and we really didn't know if we would turn it off or do something different with these machines that it would work. Now, with virtualization, with cloud computing and these things, it becomes easier. However, your application has to be designed to be turned off in certain parts in terms of what are the functions that you only need 2 hours a day, 2 days a month. Do you really need all that business functionality that you effectively assembled in your application all the time? Unpredictable bursting is a little bit tougher. That's really a combination between your application going faster in terms of resource grabbing, and the infrastructure being able to have enough capacity to help you. Again, Windows Azure, for example, keeps 20–25% capacity reserve to help you with spikes. And I'm sure your data center people do the same thing. But the key here is that your application has to be able to grow. And then remember, everybody expects you to give back these resources instead of keeping them. And that's certainly a very, very tough feat that a lot of enterprise applications, including ours, Microsoft Exchange, Microsoft SharePoint, don't do. They are designed to be for a certain capacity, and that's what they do well, and they are really not dynamic. So think about these patterns, because the marketing machine of Microsoft and everybody else who is in this business will tell your business customers about these things. It means you will be asked about them eventually, because all of these things trickle down to you as developers. Latency. Latency is one of those, I have, in my youth, quote unquote, I have never thought about latency. That was not a problem. But then I got to know modems a long time ago. So when you use a messaging client that is built on RPC on a modem, that's not a very good idea, because the wire was very, very thin and there was lots of interaction going on. So we have all learned that in SOA, for example, we send messages and we wait respectfully, quote unquote, until the service decides to answer. But we actually also seeing that demands are now shifting. I don't know if you guys are in the financial services business, but I've now seen people like NASDAQ, they are down to 80 microseconds in their trading. Microseconds, not milliseconds, 80 microseconds. So we are now seeing people actually moving servers physically together. So all the exchanges and all the people like NASDAQ effectively sit in the same data center room. And they effectively share whatever fiber network they can find so they can make it as fast as possible. So we see more and more people asking for more performance in terms of networking. The other thing we're seeing, though, is that the network wire goes longer. And we are now seeing clients like the modem, like my little phone here, or an iPad or something else, calling from wherever they are, like I did this morning, checking my email, which is actually hosted in North America, to check email. The other effect that we have is that the cloud comes in. I mentioned to you SOA before, that Windows Azure is effectively an implementation of service-oriented infrastructure, plus a lot of services on top of it. SQL Azure is a service, not a server. And the latency between a server who is deployed within the same network that you are in and a service that's guaranteed in a different network is effectively much longer than you think. So if you have written code that assumes a SQL server, not a SQL service, you need to start thinking about how you change that code, because the latency will impact your application. I've seen an application from a very well-known third-party application vendor. They couldn't make it work because the latency was 3 times as long as they expected, and their object-oriented design was pumping against the SQL server, and they were trying to do it against SQL service, and it didn't work. So if you're doing that kind of thing, meaning you're talking to SQL Server a lot and you're using SQL Server almost like a cache, you need to think again, because the latency is going to be longer. It's not much longer, but it's longer enough to impact your application. So on the one side, you have clients that access with far less network throughput than you might be used to. So think about the good old RPC on the modem. So a lot of design guidance has been given. So I know that the Hotmail team, the Exchange Online team, and some other guys have written guidance of what to do. For example, the Exchange web client now will effectively send not only the first message, it actually will send a bunch of messages, plus the first 2 or 3 texts already. So that when you open, the assumption is that when you, as a user, look at the message, you want to click on the first one and read the first one. So they go in one shot and give you as much as they can, shove down whatever pipe they have. If you delete, they actually don't delete right away. They do a soft delete, tell the user everything is good, and asynchronously send it back. The Hotmail guys do something similar, Gmail does something similar, and so forth. So what are the tricks that you are going to use to make the user experience good, while at the same time you're dealing with variable latency? And again, the other piece is think about caching when you're doing SQL these days, because SQL services are different than SQL servers. You will be able to use SQL Server in the infrastructure as a service role, but then you have to manage the whole server again. Whereas SQL Azure gives you a very nice management experience, reliability, blah, 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 all these other features that you might be interested in, but you buy it with more latency because the server is not the same as the service. Now, the other question that comes a lot on is, what is an application these days? This is a fictitious application where I schedule a service request, which is a common thing that all of us do for maintenance or restaurants or whatever. And in this case, I'm using an aggregation service. In the US, for example, there is a very common service for restaurant scheduling called OpenTable. If you've ever heard about it or if you've gone to the US, click opentable.com and find the city. It's actually an awesome service where they actually do the service coddling with their restaurants. In this case, I'm using a fleet scheduling application. So they use an aggregation service to schedule the call and so forth. How do you debug this thing? What's the SLA? Who owns the SLA if I'm doing these things? And believe me, this will become the norm and not an exception. That people will aggregate your services. Remember my REST-based comment before? That is something that is going to happen, that your applications become part of another application. And you want that to a large degree, but you also need to be aware that a lot of people are now looking at your application as a service, and that has to have a certain set of consequences. And if there is an issue, who is responsible? And part of the interesting dynamic that we're seeing is that in the cloud space, everybody talks about cloud services, but they only run on one cloud in most cases. There are certain applications where you can manage running across multiple clouds. I've seen applications that combine Azure services and Salesforce and some other things. But it's effectively you as the composer that's responsible for the SLA, for the reliability, for troubleshooting, all these things. So when you use these services, always assume that your debugging costs and your management costs will most likely go up. And that's certainly a reality that is part of this whole pattern of how we are moving forward in this cloud-based world of services and so forth. In summary, we have a lot of data coming along. I will talk a lot about data in my last slides because that is a very interesting scheme. I don't know how much we are talking about big data here, but if you have not thought about big data in petabyte scale, it's going to come in a, how do I say this, in a data container near you, because we are seeing a lot of data being gathered and used as part of an application architecture. Again, more examples later. We saw that supply and value chains becoming different. And we see aggregation patterns, we see services patterns, and so forth. Applications across platforms and new architectures that are emerging to drive, for example, HTML5 as a new forms language that we all have to at least look at. I'm not sure we are going to use it all, but we are certainly going to look at it. Now, what are some of the key concepts that we have to think about and some of the techniques that certainly I'm using when I'm driving application design? Virtualization, get over it, guys. There is no such thing as a physical world anymore, except in very, very extreme low latency trading cases. When you go down to microseconds, at this point in time, the hypervisor is still in the way. But I don't really know many other scenarios where the hypervisor is really in the way. Especially when you go down to the private cloud booth, you will see things like SR IOs and so forth. So they are bypassing the hypervisor for IOs, which is the biggest problem we have. We have network quality of service, so you can ask the hypervisor to give you a certain set of network bandwidth and guarantee it, and so forth. So a lot of these pain points that we as application people think about are becoming less important. The other piece that's happening and is something that we also have to get used to is what's called homogenization. Effectively, an application needs to think about what resource types do I want. Virtual processors, memory, networking is pretty much the only thing you will get. You might be able to say that you would like to have certain placement rules. So we'll talk about fault domains and update domains later. But as an application designer, it doesn't really do me any good to ask for 256 cores if the world of cloud computing, including private cloud computing, gives you maximum 64. And that's certainly something to think about when you design your app. I don't think it's a real big problem because most people are doing scale out, but it's certainly something to think about. Resiliency. We will talk later about moving from software to a services world and what that entails. But one of the things that we have learned in the cloud, running Hotmail and Bing and all these other things, you cannot avoid failure. When you cannot avoid something, you've got to be planning for it. And we'll talk about a methodology of how you can plan for failure and how to handle it in your code. But it's certainly something to think about where the whole world was in nines in terms of mean time to failure and so forth. Now the world is switching to mean time to restore. How fast can I get back to normal operation? And ideally, never having lost the service, meaning you run maybe with degraded functionality or degraded performance or whatever the degradation might be, but you don't fail. The idea of you being up 100% is something that should get into your head as part of your design. So whatever you can do to manage the failure and duplicate yourself and so forth is something you should think about. When you go to the Windows Azure talks of, for example, Mark Rusinovich, who's competing with me right now, I hear, he will tell you that, for example, Azure only always copies 3 times. They always have 3 copies running around. So of any single thing, if it's a virtual machine or a storage block or anything, they have always 3 copies that they manage. And that's what they call resiliency, because they don't care if they lose 2. The system automatically rebuilds itself to do this kind of 3-way clustering. It's not failover clustering. It's really more of a tandem-like non-stop clustering, if you have ever seen that technology. We talked about elasticity before. Elasticity goes both ways, meaning it goes up and down. A lot of people know how to go up in terms of grabbing more resources, but very, very few people know how to give it back. And in a real elastic cloud, and again, coming to an IT department of yours, your application will be asked to stand aside if there is a higher level scheduling that needs to take care. Let's assume I have 100 resources, and normally I distribute them evenly. And at 3:30 Eastern Time, PM, actually all people want to trade. They want to get their numbers in, they want to trade, and they want to shove money around and so forth. That's when the stock market closes, half an hour. So effectively, we are shoving all the applications that have nothing to do with trade out of the way, give the 100 resource to a trading guy, and then eventually give you resources back. And your application is not supposed to fail. So those are the things that will come out for you as part of this new pattern. Microsoft has talked about this real-time health and this management for operations since a long, long time. Unfortunately, we have not really made a lot of progress because I don't know how many of you have written a SCOM pack. If you don't know what a SCOM pack is, that's a bad thing. It's called System Center Operations Manager pack, which is effectively a way for applications to get monitored by System Center. And there is equivalent technology from Tivoli or HP or wherever the providers might be, so that your application gets managed and is visible to the management in the data center. So some of you might have done it without actually knowing it, but it's certainly something that when you move into the cloud and move into services, think about real-time health. Not a lot of great guidance out there in terms of how you write one of those things. So if you are running in a data center, grab one of your data center operators and saying, hey, what would you like to see my application tell you? How many of you know ITIL, I-T-I-L? Some people are here. Good. ITIL is your friend. If you're an application developer thinking through data centers, thinking through cloud, you should at least understand the basics. There are some very nice little booklets out there for ITIL Foundation. Very simple stuff. But it's useful to understand what is a data center guy, which is really a cloud guy these days, thinking about when they look at your application. Because they are different people, trust me. They have different ideas of what it takes to think about application. And automation, if you have any task that needs to be configured, that needs to be looked at, don't just do a UI. Microsoft took forever, and again, I'm being very open and honest with you guys, to get to this notion of automation. We are finally there that all the management applications that we ship, Exchange, SharePoint, SQL, whatever they might be, are sitting on top of a PowerShell API. So anything that you can configure, anything that you can do in terms of management, you can do in the graphical environment, but you can also using PowerShell. And that's certainly something that I would expect applications that run in data centers or in the cloud need to start thinking about. How do I become automatable? Because one of the consequences of this whole cloud thing is self-service. People expect to be able to provision themselves for your application, whatever that might mean. For SharePoint, it means a new site. For Exchange, I need to get a new mailbox and stuff like that. What does it mean for your application to be self-service provisioned? It's a very good question that I think you guys need to answer. Let's talk a little bit more real stuff rather than all these concepts and questions that I'm asking you, because I'm sure I'm giving you headaches all the time right now saying, oh my God, do I have to think about all this stuff? Good news is there is help. Not much, and we are certainly needing to improve it, but there is help. So before we talk about the help, this is effectively how Windows Azure got created. This is the application type that it actually supports. And some of you might have been around for a while. If you look at Amadeus or Sabre or any of the high-scale online reservation systems, for example, that's the architecture that these guys use. They use a load balancer of some kind. We are moving from hardware load balancers to software load balancers in Windows Azure. And then we effectively have stateless web or application servers and stateless worker processes, and we manage the state. So when anybody says stateless, what does that mean? The only thing that it means is that Azure reserves the right to shoot your VM in the head, to get effectively reuse resources without asking you to nicely, like, please drain your resources, save it somewhere, and so forth. The expectation is that you already done that you're using a cache, a queue, a blob, or something else to effectively store your stuff. The reason why this is stateless is because Azure wants to use your resources most effectively and might say, hey, this service portion I need to move to another portion of the rack in order to effectively use the rack most efficiently. So they are balancing the SLA we give you and the hardware that they have. Remember those spikes and all these other things? So that's what they're balancing and organizing. So for them to do that, the easiest way is to use these patterns of statelessness. The good thing is, if you use caches, queues, and so forth, Azure has a lot of good ways for you to do this, and it will keep that state forever, meaning 3 copies of the state, all this other good stuff that I mentioned before. These here, the web and the worker role. How many of you have written an Azure app? Good, awesome. The original CTP of Azure did something that I really loved. Unfortunately, we took it away because you asked for it, but I'll tell you anyway. Where they said the web guy, what I really call the access guy, the access tier, couldn't talk to the worker tier except through some other mechanism, for example, a queue, which allows me to scale this guy and this guy independent. Remember, I'm seeing a lot of iPads here, and I'm seeing, I'm sure, lots of phones. Think about lots of phones and lots of iPads asking for stuff, but not doing anything. Because websites, for example, a normal commerce site, traffic is about 95% browsing and 5% buying, if you're lucky. There are some websites that go up to 96% browsing, 98% browsing, and some do 92%. But most people are looking for stuff. They're trying to find the right thing before they click enter and buy. And that's a pattern that you can actually easily use with this pattern here, because here you can satisfy all the read requests using caches, search engines, whatever you like, depending on your application type. And here is the thing that actually, once the user says, please check out, it will then go and do the database thing, update message queues, whatever it needs to do in order to process the order, fulfillment, and so forth. So this Azure pattern is not something that we introduced because we thought it's a great idea, just like that. We actually have looked at high-scale applications like Amadeus or Sabre as an online reservation system, new requirements like the web client, the mobile client, and how you split the pieces apart. It also allows you to protect the database. Remember this NoSQL thing and the SQL thing? If you allow your database to effectively be only used to load the cache, and then once in a while for between 2 and 8% of your transactions to be written, you actually will be able to use asset-oriented, real relational databases for quite some time, meaning before you hit a scale point that doesn't allow you to use SQL anymore, that's a long way off. Not everybody is going to build a Facebook, I think. No offense, but not that many Facebooks around. If you do, lots of good documentation how Facebook built their stuff. But don't go overboard, because they can lose a message. You might not. So ACID is still your friend. You like ACID, trust me. It's a fine principle. It has served us well from 1972 to today. So a long, long time that has kept information alive. So this is one of the patterns and the techniques that Azure uses. And although we don't support this pattern on Windows Server today, nobody says that you can't use the pattern on Windows Server, or on Linux for that matter, because it is just a normal pattern that we automate and the infrastructure understands, but it's certainly something that you can build on-premise and say, what is my partitioning in terms of my read side, satisfying my users, and my work side, managing transactions, saving data. Now, how do you get to this thing called the patterns? Remember these spikes and on and off and all this other stuff? One of the techniques is actually the good old patterns and practices. Remember this picture? Has been around for quite some time. We're using it since a long time, but it's still good, where you're effectively looking at a presentation layer, a business layer, and your storage layer. So that's one type of decomposition. Another type of decomposition is what I call here decompose functions by roles. Windows Azure, remember, talks about a web role and a worker role. Those are really topology roles, because what it effectively does is deploying virtual machines in a certain configuration. They are really not that different, because they're just Windows Server or soon Linux, and in a certain configuration with HTTP enabled or not, and IIS and default installed or not. Nothing sexy about it, but it's a conceptual tool for you to re-architect and redesign how many roles do you need and where. Let me give you an example from Microsoft. Microsoft Exchange 2003 was an exceptionally powerful mail server. It had one problem. It had one process called mailbox.exe. And it was ginormous, that thing, and everybody effectively put code into that and added functionality and keeps on doing it. Lots of customers were kind of unhappy with it because the server went bigger and bigger and bigger. Once you have only one process, kind of hard to scale that thing. So the Exchange team went and decomposed into roles. They now have a store role, they have a front-end role, they have a gateway role and stuff like that, where they allow you to effectively spread the system out, use the compute power. For example, you can say, hey, everything is in a virtual machine. I put it on one host. So you can still get it effectively onto compute resources. But the IT deployment person can now effectively look at how do I distribute this thing. And it's not just one ginormous process. So when you use these roles, you have the topology roles, web and worker being two. But you can also do functional roles, like a gateway server or a store server or whatever the function might be. If you look at Windows Server, when we introduced Windows Server 2008, we actually decomposed the whole OS. And you have you heard about Server Core? Windows Server Core? If not, look at that. Pretty cool stuff. But the interesting thing is that we now have Active Directory role, file server role, and so the whole functional system of Windows Server, which was not necessarily one thing like Exchange, but was pretty big, is now decomposed. And only what you need is it getting deployed. And the IT administrator has the functional mapping and can say, I want the file server only CDFS. What's your equivalent? How do you get to a point where you can use this basic stuff and then do the functional and role analysis to think about on and off? If I don't use the file server for 12 hours a day, can I turn it off? Is it effectively something that the infrastructure could take over? So there is a lot of composition techniques around. So IBM has a component-oriented composition model. Microsoft has a business-oriented composition model in addition to the technical stuff. So lots of good ideas around, but it's really you that has to make an analysis of what is my functional set. And if it's a small app, don't bother. But if it's a ginormous app with lots of resource requirements, you have to think about starting breaking it apart. And how do you do that? The other thing is asynchronicity. Asynchronicity. Thinking through how you deal with asynchronous behaviors. Asynchronous, despite the pain that it's going to inflict on you, meaning debugging, race conditions, all these other things, is your friend. Go back to the latency examples, meaning the clients being possibly very slow, but still sucking down information. So how do you deal with that? And then your services that you depend on also not necessarily operating above the speed of light. So you have effectively two sides of latency that you have to think through, and asynchronous behavior is your friend on these things. Caching, queuing, and so forth is what's going on. A friend of mine built this slide, and I like the way he says is, how do I couple the process from the process trigger? Simplest example is browsing in a website, putting it into a shopping basket, and then at some point in time saying, check out. Check out then is the process. The checkout, clicking the button, is the process trigger. Until then, everything is browsing, caching, and so forth. I don't need to bother my database because I have the information in the cache. A key thing around asynchronous behavior, again, the development process is important because debugging is becoming more complicated. Good news is that all the technologies, at least in the Microsoft world, that you might depend on, ADO and so forth, are supporting asynchronous behavior. HTML5, by its very nature, is asynchronous. And it has natural behaviors built in to allow you to effectively build asynchronous applications very easily. MVC4, if you are not engaged with that technology yet, go look at it. It's very rich and powerful for that. But my key thing on this application thing in terms of asynchronous is information modeling. A lot of times when I talk to business application people, they say data is data. And I have to unfortunately tell them that that's not true. Because there are certain data that you can cache, and there are certain data you can't cache. Let me give you some examples. Most of you will have heard the term reference data or master data, which effectively is immutable copies of data. Think about a shopping catalog for an online shopping thing, which you used to get in the mail. Some people still do. My sister-in-law, for example, still uses paper catalogs for some reason, but she does. The first thing that actually, when you call that catalog person, is which version of the catalog did you use? And then it's business policy how far back you support this thing. And everybody thinks, yeah, that's cool for the paper stuff. Actually, it is also true for electronic copies. Because once you take it out of the database, you effectively stamp it, version it, and saying, this thing is now valid for, ideally, a long time. Because if you don't have to change it, you don't have to recache and requery. But that is dependent upon your application patterns. Time is the thing you want to play with, meaning as long as you can not change things, awesome. If you have to change every 5 minutes, fair enough, do it. But have a policy in place that says reference data is available so that, for example, my iPad friend here can actually take it on his iPad and go around for weeks on end. And he doesn't have to go online to download the orders list or the parts list or whatever the heck it is that he wants to download. So having a strategy for reference data that includes policy, how long that thing is valid, so that you have to refresh very little if possible, is one big thing to think about. Read requests should always be satisfied out of reference data from a cache. Good. Second type of data we talk about is activity data. Ideally, what you can do is create session-oriented data like this shopping basket. Remember that thing? The shopping basket is either mine or yours or somebody in the back's. Nobody else has access to this data. It's completely isolatable, and I can actually pass it around. If I allow it, I can copy it to the iPad, and that person can run around with it for a while, and it's still valid. Perfect data, great isolation. Don't need to bother my database with it. Remember, it's all about protecting that database so we can scale it and use it for a long, long time. The last data is the nasty one, which is what's called shared data. And shared data, the best example that everybody uses is inventory. I need to know how much stock on hand I have for a given thing, whatever that widget might be, the books, and so forth. And sometimes that's true. Certainly the release of nuclear warheads, I would really like it to be a locked transaction, one at a time. Nobody can do optimistic reading or whatever. So certainly clear. But when you think about Amazon, I love the way they dealt with the inventory problem. Usually available in 48 hours. I like that. And guess what? How many of you have bought on Amazon? We like it too. We didn't need to know that they had 5 of them on hand of 5 million. We actually really didn't care. As long as the SLA said 46 hours, 48, 96, whatever, we were cool. So even if you have an inventory table with the right information modeling and the right business policies, you can use asynchronous behaviors, not only in terms of technology, but also in terms of the application flow that you're running. What I call this is this brutal behavior of the real-timeness. It's always business real-time, by the way. So if you talk to real signal management people about real-time, they will tell you that no operating system that we ship supports that kind of thing, etc. So if you use .NET real-time, doesn't work. So when we talk real-time, it's business real-time. And that's where a lot of times we use our ability to go to the database and query for the latest information as an excuse to not model information correctly and not think about tricks like the Amazon trick. There's a great paper, SOA days, old, but still valid, from Pat Halland. I don't know if you remember Pat. He used to be at Microsoft. It's called Data on the Inside and Data on the Outside. It's on msdn.com, .microsoft.com. If you query Halland data outside, you'll find it. And it's a great paper, and it talks about these 3 data types. And it has a 4th one, but let's ignore that one for a second, because it really is important to think through how you model your information. Asynchronous apps fail if the applications are not, or the information is not modeled correctly, because you're making assumptions about the data that are not true. For example, I was with a very large retailer, and they had used distributed caching. They used App Fabric caching, great technology, but it's not a database. It's a cache. But they used it as a database and got themselves into trouble. So we had to figure out how we model the information after the fact. Very expensive thing to do and very nasty because you have to rewrite your code. So asynchronicity is important, but it goes with information modeling. Otherwise, it doesn't work. It really doesn't work. I've talked about elasticity before, but one principle that I want to also lay down as a suggestion is something that I'm working with my consultants in the field for our applications, is what's called a scale unit. A scale unit is a concept that a lot of the cloud guys started to use, especially in startup mode. So it's 1995. You have this brilliant idea called webmail, Hotmail. How do you scale your service? Is it 5,000 users, 50,000 users, or what is this now, 1.2 billion mailboxes? How do you do that? So these guys didn't do the capacity planning like I said before. They said, no, let's come up with a defined capacity and design capability and build a scale-out architecture so that we can take, let's say, 50,000 mailboxes, 100,000 mailboxes at a time and scale them out. In 2008, last time I checked, Hotmail had a scale unit that was based on a petabyte of storage. So a petabyte of storage, and then the accompanying servers were supposed to support a given number of mailboxes and users, and that's how they scaled out their clusters. And that's a great architecture for you to think about when you think about capacity planning in the modern world, which is really reversing, because you want to start with a given capacity and then add to it, rather than saying what I have another talk called Green IT. One of theirs, I'm talking about success is a design tenet. So I've done a lot of SharePoint work, like everybody at Microsoft Consulting. For some reason, that seems to be popular. And we always talk to the business people and saying, it's going to be 150,000 employees. Everybody will collaborate like crazy. So we give them 50 megabytes or gigabytes of blah, blah, blah. We go do the design, and we come up with an enormous number of servers and a lot of storage. 2 years later, you come around and saying, yeah, only 50,000 users really. They didn't really collaborate that much. And so a lot of the storage is idle, and the machines don't do much. With this approach, you can effectively look at providing capability that the business wants, but chunk it in a way that allows you to move it and scale it out. So think about it. It's a very cheap way for you to get to a much more elastic mode, because this allows you to grow, at least in a stable fashion. And the other reason why scale units might be something you should think about, even if you move to things like Azure, because Azure's VM time, I don't know what it is, $3 a day or something like that. It's a ridiculously low number. But it takes you still between 2 and 5 minutes to provision a new VM. So it's sometimes cheaper to grab 3 VMs at a time than just keep one and then remove one and give one back and so forth, if you're thinking about elasticity. So scale units is not only something for growth, it's also for something to taking back. So you're saying, I'm taking back this number of units of scale. The other piece that is really close to my heart, and I believe something that we as software developers need to think about, is this thing called a service. A lot of you will say, well, I'm delivering services. I'm doing either web services or REST or something like that. That's clearly one aspect of service orientation. But the bigger aspect, especially when you think about cloudification, is service management, SLAs, all these other things. I'm dating myself here a little bit, but some of you will remember that kind of picture, which is a closed room, a couple of people that had physical access, either by key or some other thing, and there was no connectivity. Awesome. It was very secure, and so forth. But the bigger thing was that there was, and our IBM friends have done an awesome job there was a book for every single thing that an operator had to think about. If the thing beeped or if the thing did this and that, you opened the red book, you read through it, you got to do this. And when you think about your applications, where is your red book? How does it work in terms of an operator is looking at your app and it doesn't do what the user or the operator expects? How many times have you sat in front of one of your whatever favorite application and the thing just turns and says it doesn't tell you what it does? It drives me crazy when it does that. Think about an operator in your data center thinking about the same thing about your app. Saying, what the heck is this thing doing? It's getting slow, or it's grabbing memory, and so forth. No idea. And that's what we really need to start thinking about. The other interesting fact that I hadn't thought about, a friend of mine thought about and said, you know what, Uli? We have now the first generation of people that have not been exposed to a mainframe. They actually have not seen, they have either only seen Unix or Windows in their whole life. They have never seen a mainframe. So when we talk about red books and process and stuff like that, they look and say, what the heck are you talking about? This is GUI stuff we set up and we drive from there. Those things are over because while you can attach a debugger to Windows Azure, it's not really something you should do because it's a service, remember? That thing is supposed to be up 100%. So debugging is not something that you can do in lifetime. And so certainly something to look at. Another initiative I'm driving is what we're calling fail-safe. So how do you write an application that's really fail-safe? And this is a graphic I stole from one of my guys, just to show you what the dependencies are that you're actually effectively taking. And this dependency tree, by the way, is independent if you host it in your data center or in ours. So there's always third-party things you're depending on. Windows Server starting with that. And there's lots of other things you depend on that effectively impact your SLA. Platform services, your own stuff, the various applications, the cloud environment, infrastructure, the data center, traffic management, other data centers, and so forth. And we haven't even talked about the connectivity between those guys. A lot of times, that is something that you don't need to think about because your infrastructure people will think about it. But now, when you look at the cloud, you have choices. Remember this choice thing? And it really tells you, hey, you could deploy in North America only. You can deploy in North America and Europe. You could deploy in Asia Pacific or in all three regions. You can fail over here, move it there. What is it that you would like? And you as an application have to start saying, well, what is it what I would like? Do I need access everywhere, fast access? Do I, for example, say all my caches are everywhere and my read transactions are only, let's say, in North America, or we are here in EMEA, so we do Amsterdam or Dublin as our data center locations. So you effectively have fast read access, and because of asynchronous behavior, you drive the queues into one data center or in two data center locations in one region. So there's lots of choices you can make, but effectively your SLA will depend upon how you manage all these choices. And Bing, for example, is by now a 100% operator-free environment. It effectively repairs itself. Lots of work went into that thing to do that, so it's an extreme that I don't think you want to go to. And it effectively does it globally across N different data centers. So we really deploy Bing automatically and in containers. So there's no racking and stacking. There is no software install or any of this stuff. It boots. It becomes its image, its role, and it goes from there. And the data is being distributed automatically between the environments. A lot of applications can't do that today, which is fair enough. But a lot of applications will be asked to think about it because one of the typical business strategies for growth is geographic expansion. So I worked with a major wholesaler in the US, which had a great presence in the US and Canada, but they wanted to get to Australia and they wanted to go to China, and their path there was to go to public cloud environments. On-premise for US and Canada because they had the facilities, but in the other environments, go to public cloud and go from there. So lots of interesting choices. Talked about some failure management before. FEMA is an old method, effectively failure management analysis. And it effectively allows you to look at failure points and document them. When you look at object-oriented design or component-oriented design, sometimes we see behaviors in our own code, so it's not just customer code, where we actually pass the message of errors along. And we give you a hex code of some obscure thing. You know what these poor operator people do with those hex codes? They actually Google them or Bing them, depending on what they like, and then they find other people who Googled and Binged them and said, this actually worked. And you as a developer say, what the heck did these guys deduce? Because there is actually no documentation, really. Just to give you an example from Microsoft, there was an event log entry that had some hex code in it, and it says the operation succeeded, memory couldn't be written. Like, okay, what the heck does that mean? And so they binged and Googled and did all their things. It turned out that the C drive was full. So it was trying to write into an event log on the disk, and the disk was full, and so it succeeded, because that's not the condition it actually had, but the C drive was full. It took a lot of people to find out what the heck was going on. And so when you write error messages, first of all, do two things. Write them as close to the error that you, or the failure you have, and then write something sensible in there. Because this kind of message, like it succeeded, but the memory couldn't be written, is not very helpful to nobody. And here is a piece of code that effectively talks about, talks about how a database can offer. There was supposed to be other stuff in the slide that talks about how many failure points are in here. So the database is a common failure point or any external configuration item. And then how many failure modes can you effectively find? And while it is, of course, not feasible to go through all failure modes, you should at least understand what your dependencies are, what the failures that can happen should be there, and then deal with them as close to the call as you possibly can. Remember, you're now a service, not a software anymore. So that means also if you can repair it, do so. A simple repair story for Azure or any service-oriented environment is retry. Because the service might be busy. I'm seeing smiles. How do we say this? You have no idea how much code I've seen where there is no retry. People are writing code and they don't retry. And now that we have shown in our sample code how to do that for SQL Server and the database connection, I'm seeing more of that now. But we still don't see people reusing, retrying, writing to the queues, as if that was different than to the database thing. And so retrying is a very simple fix pattern for this kind of failure mode analysis. But there are others, and there is a great book, Fault-Tolerant Software Design Patterns, that talks about the experiences in satellite design and router design for telco-grade routers. Not that you need all these patterns, and some of them are implemented actually in software. But for example, a watchdog pattern is something that most of you will have heard about. It's something simple to implement, to say, hey, is my service still running the way I want it to? You know your service. And again, some application server environments support that for you, but that's generic code. There's very simple things you can do to make your code much more reliable than what we do today. So think about failure mode analysis as one of the things as a developer that you've got to do. It's similar to threat analysis and threat modeling. Just here you're looking at failures rather than threats. But something that we should clearly push and document, and then write a sensible error message. Don't write operation succeeded, memory couldn't be written. That's not a good thing. Fault domains, update domains, everybody know what that is? Have you heard about that topic? So what is your fault domain design? Some of it is you can just rely on Azure and so forth to do it. But their Exchange guys, for example, have their own fault domain design because they're a complex application and they know what their high availability strategy is. They also have their own update domain design for you to place the DAGs in their language, the data access groups, in a certain pattern so that they are available and can be upgraded and so forth. And again, in most cases, you will be able to use what Windows Azure or a Windows private cloud environment allows you to do. But in some cases, you might want to think about what you want to do there. We talked about monitoring health performance before, so I don't want to go into that one again. And then talk about these other things. So I'm very, very bad about explaining this one because I believe that a command prompt is an awesome user interface. But I appear to be not in the majority. So from that perspective, a lot of people are thinking about application design these days. Apple has done an awesome job of raising the standard to a point where all of you guys are now application designers and user interface designers. And a lot of user interface design that I have seen looks like a command prompt guy trying to do a user interface. like me. So don't hire me for that kind of thing. Not a good idea. But part of the problem is that we now have been put up to a standard of simplicity, of user experience that I have not seen in a lot of enterprises. And guess what? Consumerization of IT is not just a benefit to everybody. It's also a pay load that you have to start thinking about. And that's certainly something to consider. How many of you have played with Kinect? If you haven't, go. It's awesome, and it's just mind-boggling how that stuff works, because it allows you to read the stuff and scanners and motion and so forth. Awesome. But as you can see here, it works when you have a lot of space. Trying to do Kinect in an airplane seat might not be a great user experience. The purpose of the story is always understand where your technology or your approach is being used. Sometimes touch might actually be not great, because if you have a very big protective glove on, you might not be able to touch things. Actually, touch might work, where your checkboxes might not work because the fingers are too big. So you have in a plant environment or wherever you might be. And so when you look at these examples, and they are very drastic, so it's a good memory kind of trigger, but what is your environment that you're going to be used in? If somebody is crawling around in a fuselage using your laptop to try and figure out what he's or she is supposed to be doing, again, a certain set of interfaces might not work. So user interface is not just about basic colors and whatever font. It's also something about where it's going to be used, how is the user experience going to happen end-to-end. There are certain environments where gestures and speech and so forth are great. In certain other environments, it doesn't work. And that has to be something that is calculated into the experience rather than ignored. You have seen this enough, so I'm sure you're either bored, you hate it, you love it, but there is one big thing that we as Microsoft don't talk a lot about here. If you think about these tiles, and while they are all consumer tiles oriented, Windows Metro is an information architecture. It effectively looks at how you expose information. So I would expect that over time in enterprise deployments, people will say, yes, I have a user persona that's looking at my private mail, Facebook, or whatever, if you allow that. But there is also a business role. So could there be orders here or complaints or whatever the job function is that shows up in the tile and automatically update? What could that look like? What is an enterprise information model for either your enterprise or your set of applications look like that you can display here? I haven't seen great examples of that yet, because a lot of this is consumer focused, so you see Wikipedia and whatnot as an example. But I think it's an opportunity also to step back from either hate it or love it and say, what is the opportunity to, for example, bring information that's relevant to the user right here and there without the user having to open an app or be in the app. So it's not just about, yeah, it's nice and tiles. It's actually an information model that has opportunities for enterprise application developers as much as it has possibly design challenges to think about. This time, actually, I'm going to talk about it because in North America, I ran out of time. The other piece that we, as application guys, need to really think about is data. And not data in the sense of storing it and so forth. We talked about that a lot. But really thinking about how do I use data to understand what my users tried to do, did do, and how do I improve my behavior. Just to give you some fun facts. Bing, which is really only effective in the US at this point, and in England, is currently running at about 250 petabytes of a data warehouse, quote unquote. 250 petabytes of data that's being used. Again, what have we crawled? What have the users been doing? What queries were popular? What results were actually the first 5 clicks in terms of first 5 results? What users have been clicking the first 5? How many people had to go to the second page? All these questions and statistics are being used in real enough time, so mostly in batch mode, to figure out how to improve the search experience itself. So it's using insight, data warehousing, quote unquote, to really drive the application behavior. If you think about that kind of thing, what is your application going to do to become smarter over time? Unfortunately, this business intelligence thing is one thing that happens in Excel. Every Microsoft guy will talk about, oh, BI, that's Excel. And while that is certainly true and important, actually the real intelligence is actually in the apps. Because the apps, on the one side, generate the data that's being looked at in Excel. And on the other side, it actually executes business processes. It executes business policy. Remember the shopping cart example, usually available in 46 hours or stuff like that? That's a business policy. How could you improve it, and how could you do it dynamically? Our Bing friends are now looking at using this quote-unquote data warehouse in real time. So that when you go in and query for something, it will actually look at the query behavior, look at the page load, and so forth, and in real time change the behavior. So that's how extreme these applications are now going. Just to give you some fun facts, these are old, about the amount of data that's being generated and the amount of data that you could possibly use. If you want to try something interesting, Bing, I believe, has done a pretty good job with the social stuff. Go and switch, if you go to bing.com, switch the configuration to US English. You actually will be rerouted to the US search engine rather than the European one. And there you can actually hook up and sign your Facebook account to allow Bing to use your social graph in real time to influence the search queries. If you want to do that, it's a different story. But try it. It's just a fun little thing because you can opt out any time. We have built applications like this where we used insights. On the one side, what did users do? What did they buy? What were the checkout patterns? What were the abandoned shopping cart patterns and all these other things to help online retailers improve the way the website behaves. Everybody wants to support recommendations now. People who bought this, bought that. And so there is a lot of technology available that allow you to do that. Big data in terms of Hadoop is one environment. Fast search is another environment that actually does have a recommendation engine that is being used by a number of very large online commerce environments. And I'm using it, for example, for my intranet. So I'm actually also using it for knowledge sharing because I'm recommending pieces of IP or documentation that another user might want to use. What recommendation patterns could you use? Because remember, we are in this thing called Generation Me. It's all about me. My application, meaning you being an application designer thinking that you are in charge, it's actually the other way around. Because users are coming in now, and they're expecting you to work for them. That the application changes dynamically based upon what the user tries to do. And we give you a very prominent example. Dell.com, a very big website, $25 billion in revenue, I think, by now. They actually are trying to deduce if you're trying to buy something or if you're trying to get support from something. And the website changes dynamically based upon the context. If you're buying something, they will give you recommendations for whatever gadget they have on sale. If you're looking for support, they go into a completely different mode. That's a simple switch, but there's lots of ways for you to use this kind of thing. And believe it or not, Facebook and social group behavior actually is important, at least for internet-facing sites. I'm not so sure yet on intranet sites, but we just announced the purchase of Yammer. So who knows what the enterprise is going to do with social computing and what your application is expected to change when users say, hey, I want to work with A, B, and C, and whatever these guys do, I want to know about so that I can look at it and do the same thing. And that's not just for documents or users or people. I believe that's also for business processes. Saying, this guy did this, he made that recommendation, whatever that might be, to my customer. I would like to know about it. And not in 5 weeks or years, actually in real time. I want to know it right now. So how do you do this? Effectively, what you can do is look at your environment. This is a commerce example, the easiest to explain and show. And not only look at session data, but also look at what I call data in motion. The user behavior in terms of where did the user click? what navigation path did he take. If you look at any .com environment, portal, MSN, whatever you like, they actually track where users click, and they track where users went. In order to give you suggestions, A, we want to know who you are as much as possible, and we are not prying into your data, but we are looking at behaviors and saying, based upon this behavior, we believe you are that kind of person, and you might be interested in that kind of advertising, obviously. But at the end of the day, the scenarios are endless, and certainly something that you can look at in yourself. Let's go back to the online banking app. The online banking app today is fairly static. It shows me accounts. It allows me to move money, pay bills, that kind of thing. Great. Wouldn't it be great if in real time this thing tracks of what other people do, for example, and saying, hey, you seem to be moving, let's say, euros into, what is it, US dollars. Lots of people are doing that right now, so you might want to either hold off, or here's a better way for you to do that, so you can in real time give simple recommendations of what to do. Either here's a better way to navigate the app, or here's a better way to look at activities that you can do. And that's certainly something that we will support with upcoming technologies. I can't talk about it because SharePoint next version is being announced sometime later this year. But this, for example, will be a native pattern that we are looking at supporting end-to-end. How does it work? We look at what you do in terms of purchase activity, user navigation. We feed it into two things. One is a profile environment, and we then feed it into a data mining environment. And the data mining environment effectively spits out certain artifacts. In the case of a search engine, like FAST, it actually allows you to create either changed indexes, or it creates an additional information module or information item called recommendations with the link to the originating item. So you're looking at, for example, people that bought Lenovo laptop computers actually also bought the case for it, or they ordered a mouse for it, or if anybody who ordered an iPad actually ordered the stand with it, or whatever the combinations might be. And generally, we track things like user to user, user to item, and item to item. I'm done. And last but not least, real time. How many of you have heard about Stream Insight as an engine? We're doing our usual good job of hiding great technology. The Stream Insight engine is a part of SQL Server, and effectively, as the name says, is a stream management engine. Or if you have heard the term, complex event processing. So effectively, you're feeding it events, like, for example, user clicking on a site, user doing something in a shopping basket, or user moving money from account A to account B, and formulating data, an event, giving it to the event engine, and the event engine says, I've seen this before, let me look at it, and saying, this is the recommended action. In the simple case, what we do here is, for example, we either feed it to somebody else, or we feed it back into the application and change, for example, session variables. So the next time the user does something, we change the behavior of the user, whatever that means in terms of one example we did for a very large customer was the user looked at buying Xbox. And the first time he came, we showed him the hardware first, Xbox Kinect and all these other offers, and games came in very low as a search engine. The second time, when he clicked as the first action to games, we flipped the hierarchy around and said, we show you games the next time first, because you right away went to games. So we assume you have the hardware. We're not excluding the hardware, so it's still there in the search result, but it's deprioritized or put down. So lots of these kind of things you can do with Stream Insight as a real-time engine. Remember the online banking app where you could say, I want to have real information at this point in time? Stream Insight is one of the engines that you might be able to use. And if you have licensed SQL Server, guess what? You have licensed Stream Insight. It's actually part of the SQL Server package, although it's not part of SQL Server in terms of implementation technologies. It's an in-memory stream and time series management system. So if you're in the time series business, complex event processing, Stream Insight is worth a look. And with that, I thank you very much for your patience and for your attendance, and I hope you enjoy a great TechEd here in Amsterdam, which is a great city. Thank you very much.